Lesson 1.8 notes. Lesson 1.8 is about explicit formulas for sequences. The first vocab word that we're going to talk about is a sequence. A sequence is a function whose domain is a set of all positive integers. So in other words, 0, 1, 2, 3, 4, 5, all the way on up. Or it's the set of positive integers from a range from like A to B. So it could be from like 2 to 5 or 10 to 20 from a certain range. As you can see, I wrote that in there in the box. Below that, a sequence is an ordered list of numbers or objects, so it's in order. Each item in a sequence is called a term of the sequence. And we're going to go through an activity to help you understand what that term means. Okay, here's the activity. The collections of dots below form the first 5 terms of a sequence of triangular arrays. The number of dots in each collection form a sequence of numbers. So term number 1, that's term number 1, has 1 dot in it. Term 2, in other words, the second item in the sequence, it has 3 dots in it. Term 3, if you count the dots, it has 6 dots. Term 4 has 10 dots if you count all the dots in the sequence. We're counting these dots. And term 5, if you count all those dots, it has 15 dots. So that's step 1. Complete the first table. So that's the first table to show the number of dots in each of the terms pictured. So that helps you understand the terms. That's each item in a sequence. In step 2, use any patterns you see in step 1 to complete the second table. Well, if we look at how the number of dots are increasing, it's going up by 2 from the first term to the second term, then up by 3, then it's increasing by 4, then to go from 10 to 15 you have to add 5. So for the next term we need to add 6. So 15 plus 6 would be 21. We added 6 from the previous term. 21 plus, we're going to add 7 this time, because there's going to be 7 more dots. We're going to add 8 to the next term, so 28 plus 8 is 36, because there's going to be 8 more dots if you kept drawing them out. And finally, the last one, we're going to add 9, so we have 45 dots in that 9th term. And that's how we would do that. That's completing that second table. In step 3, explain why the set of ordered pairs, the term number and number of dots, describes a function. Well, let's look at that. We talked about functions before. So for every x value, in this case the x value is the term number, there has to be a y value, and we have that. And if the x value repeats, or if it's the same number twice, then that y value has to be the same. In this case, the x value doesn't repeat, so we don't have to worry about that, but yes, it is a function. And this sequence describes or defines a function whose domain, so we're talking about that domain, all the x values, is a set of all positive integers. As you can see, I wrote that there. It's a set of all positive integers from 1 on up. It stopped at 45 in this case. And that was the rule for a sequence. That's what defined a sequence. Using subscripts, and a subscript is a number that goes lower. So in this case, the 1 for the t sub 1, and that's how we would say it. T sub 1 equals 1. So the first term, the number of dots is 1. T sub 2, or that second term, equals 3. There's 3 dots in that second term. T sub 3, that third term, has 6 dots. It equals 6. The notation T sub 3 equals 6 is read T sub 3 equals 6, just like I was reading them. The subscript is often called the index. So that 1, or that 2, or that 3, that's called the index because it indicates the position of the term in the sequence. In other words, the first term, or the second term, or the third term, we could write the 9th term as T sub 9 equals 45. Knowing that the 9 is the index and it indicates that it's the 9th term. Okay, at the bottom it says writing explicit formulas for sequences. We're going to talk about that. So many sequences can be described by a rule called an explicit formula. for the nth term of the sequence. The nth term meaning like the 10th term or the first term or the 12th term. These formulas are important because they can be used to calculate any term in the sequence by substituting a value for a. So in other words, we can figure out any term in the sequence without having to go through the whole, starting with first term and the second term and the third term. We can jump around and figure out maybe the 100th term of a sequence without having to figure out terms 1 through 99 first. And we do that by using these explicit formulas that we have. We're going to do some practice with that on the next video and go through 4 different examples of that.